Hello, folks, and welcome to Rational Science, directly from Frankfurt, Germany. We had lousy weather here in Germany for the last 3 months. They talk about global warming. I haven't seen the sun in 3 months. I have plants out there. I don't know how they get their sun because there has been no sun. It's been raining or cloudy over here. So, is there climate change? Probably it is, but if it is, I don't know if it's global warming. I think it's global cooling, at least from my point of view over here. Okay, what we do here is a little bit of physics and we do a little bit of extinction as well. And today we're going to be doing, as far as physics is concerned, we're going to look at the speed of light. Can light go faster than light? And then we're going to start with extinction, okay? And let me start with something else related to extinction. You'll see how it develops. And it's got to do with this COVID bug. And some people gave me a little bit of static because I got my vaccine the other day, okay? And so there were several comments that I got from people. And here's one of them. The fellow says, I don't take medicine from people I don't trust. I can't believe you took the sleever, Bill. Yeah, I did. No biggie. You know, what can I say? I took it for a different reason. Okay, and I'll get to that in a second here. Another fellow says, you got the kill shot, Bill? It too, brute? Yikes, nice knowing you. If you aren't dead after September. Yeah, and so we have good old Caesar there being stabbed by COVID jabs, COVID vaccine jabs. Yeah, yeah, maybe that's the way he went out. I don't know. Maybe they stabbed him with vaccines. Another fellow says, I like this one. He offered a solution. He says, sorry to hear that, but hopefully you were smart enough to put a fake arm towards the Satanist who wanted to put the poison into your body. Yeah, that would have been a good idea, you know, put a fake arm, my prosthetic arm. Okay, so there are a lot of people who don't agree with this vaccine deal, okay? One fellow did. He said the following. He said, I got my sugar water shooty jab a couple of months ago because I am not a diabetic and I like being able to go places. And that's essentially my situation. You know, I like to travel. I do travel. I did travel about a couple of months ago. I think it was May or June, and went to Iceland. And they gave me hell. I mean, they put me in a hotel for 5 days. I had to be under quarantine. And now I'm planning on going in a couple months to a much less advanced nation. And I don't want the hassle. I really don't want the hassle. I've got a friend of mine who, when they started putting these, requiring these masks, she said she wasn't going to put it on. And so she went into supermarkets, she went into the bus, she went into everywhere and didn't use a mask. And the problem was she got her way, right? She's a tough cookie. But the problem is, you know, everywhere she went, she had to fight, had to struggle. And the question is whether you want to go through all that, you know, and my decision is not to go through all that. You know, I'd rather be on the safe side. Now, I don't care about this vaccine at all. I didn't get the vaccine in a year and a half. The only reason I got the vaccine is I got to travel, and they're going to make life miserable for me when I get there, when I come back here. Here, if you come from a fourth world nation, you know, they put you on quarantine when you come back, 10 or 14 days. I don't remember anymore. And I don't want to go through that. I mean, I don't care about the vaccine one way or the other. And let me tell you a little bit of history. You know, my mother, she worked for the Swedish American Hospital, and she also worked for a dentist. And so she saw a lot of doctors, she saw a lot of the operations and so on. She also looked at what the dentist did inside your mouth. And after seeing all that, she became an atheist in medicine. In other words, she never trusted doctors again. I don't think she ever went to a doctor again. Okay, and she faked all our vaccines. You know, all the certificates that I had when I was a kid, they were all fake. She faked them. She didn't want us getting any vaccines. So I don't have any idea what vaccines I have taken. I know I have taken the Sabin, what is it, the polio vaccine, that it was a little sugar cube you had to eat. And that's because they came to school. You know, I was 9 years old at the time. They came to school and they just put everybody in line, started giving them the vaccine. They didn't ask anybody, you know, like if you're a Jehovah's Witness or anything like that. They just gave it to you and you stood in line, they gave it to you. And then I know, you know, I was bitten by dogs 7 times in my life. They had to take me to the hospital, and I know I got the rabies shot at least twice. So, you know, I have some vaccines that I know of, but, you know, the common ones, I have no idea whatsoever if I ever got a vaccine or not. And that's because my mother fought against vaccines. She fought against a lot of the um, procedures that the doctors and dentists did. She thought a lot of them were unnecessary. She was very familiar with the fact that companies would come to sell their products through the doctors and giving them a cut of the profits. You know, she was well aware of all that. And I'm not talking about 2021. I'm talking about 1961. We're talking about 60 years ago. And so she grew very skeptical of doctors and the whole medicine world. But there's a part of the story to this, and that's that she died at the age of 62. And she could have lived probably a lot more years, maybe to the 80s for sure. But she died relatively young, and she died of cancer to the uterus. Now, that was a relatively simple operation if you catch it on time. You know, you go in there and if you know the uterus has cancer, you remove it, and women live many years after that. She didn't do that because she didn't trust doctors. So she didn't go to the doctor to get a test or anything. She was having problems, and she kept it to herself. And you know, I think that that was the cause of her death. The fact that she did not go to a doctor when she should have. Now, you know, I went to a doctor. What was it? A couple of years ago, I got an operation. You know, they removed a big circle. As far as I know, this is all I know about it. Okay, they removed something from my prostate, and they also removed a stone. In fact, here you see the stone. I don't know if you see it there. Okay, I hope you can see that. Anyways, they removed the stone. Looks like a limestone there. Okay, and you know, I had some kind of problems, so that's why I went to see the doctor. You don't have a problem, you don't see the doctor, other than, you know, for a yearly test or whatever. Other than that, you know, you got a problem, you go see a doctor. That's normal procedure, operating procedure. So I go there and they said, look, you need an operation. We need to cut your prostate. Okay, so they went out there, made a hole in it, pulled it out, and while they were there, they removed the stone. Now, you know, someone might say out there that, well, Bill, you know, that's what they told you. Maybe they went to a quarry, they got a little bit of stone, and they told you, hey, we removed this from your bladder. Well, yeah, you can have all kinds of conspiracy theories, you know, out there. Someone could have said also that my mother probably didn't have colon cancer to the uterus. Maybe she should have eaten carrots and she'd be okay. You know, I get those kinds of answers. People, you know, your arm hurts, your shoulder hurts. You go to the internet, you look it up on Google, shoulder, you know, pain. And you see a million people there saying different stories, and you see one says, oh, I don't know, if you eat grapes, your shoulder will hurt. And the guy says, yeah, I eat a lot of grapes, so maybe that's why my shoulder hurts. And then when he meets you, you say, you know, my shoulder's hurting. Do you eat grapes? Well, I ate grapes last year, on a Saturday. Ah, that's what it is. Eating grapes makes your shoulder hurt. You get these kinds of answers out there. And that's because everybody today is a witch doctor. Everyone. Everyone's a dietologist. They all know everything about diets, what you should eat, what you should not eat, what proteins are, what fats are, what carbohydrates are. They know it all. And so they worry about what they eat. Should you eat this? Should you eat that? Lettuce is good for the heart. Pumpkin is bad for your liver. I mean, they know it all. And, I'm not into that world at all. I don't care about, what I eat what's on the plate. I usually eat what I like to eat. And, there was a teacher in college that said, anything you put in your mouth is poison, has some kind of poison, It's good for this, but bad for that. And there's no way out of it. We're all going to die eventually. We can't beat Mother Nature's gravity. Gravity pulls on you. Eventually, she has her way. So we're all going to die one way or another. If the gods of Olympus came and said, Bill, I'm going to give you the same options that I gave Achilles. You can live a very short but a glorious life, or a long, uneventful life. Which would you want? Well, I think I would go with the Achilles version. If he gave me a choice, Zeus or whoever gave me the choice and said, Bill, you got to stop drinking beer and wine and you'll live 5 more years. No. I'll take the less 5 years less and continue to drink beer. That's the way I am. I don't care. So it's one of those things that everybody has to decide for themselves. But I'm saying there's a lot of people out there who are very scared of this COVID thing from two directions. Some people believe that there's a big problem out there and they want to get their shot so they're protected so they don't get the virus, because apparently the virus kills. Other people say, no, it's all a hoax. Don't worry about it. This is all government propaganda. And the only thing I've got against that is, again, like I said last week, you can't have Cuba, China, Russia, North Korea, Iran, these countries which are enemies of the United States agree to that there is a virus out there that's going to kill the population. I don't think they all got together and decided on this. So I have to believe that there is a problem out there, okay? And the only issue there is that it's counteracted by the fact that, companies are making good money with this vaccine and all this other stuff that's out there. Governments are charging, to get the PCR test and so on. So there's a lot of commerce involved. And then, like I mentioned the other day, you have like the Sputnik, the Russian vaccine. It's not allowed here in Europe. It's not, hasn't been approved. And again, you would think that if it's for health reasons, anything should be accepted. Hey, we got to save our population any way we can. And that's not the case. They say, no, we're not going to accept your vaccine. We want to make money with our own vaccine. And so there's a lot of that going on. And again, that's why a lot of people are skeptical. But all I can tell you is, in my case, I'm going to be traveling. I don't want the hassle, and I don't care if they put poison in my arm or not. As long as it doesn't kill me, or like I told my doctor, I said, can I still drink beer if I get the shot? She says, yeah, sure you can. I said, okay, I'm going to use that as an antidote for whatever poison you put in my arm. So, yeah, I'm not into that subject at all. I don't care one way or the other, as long as it doesn't kill me. If they want to put a little poison water or fire water or whatever they're put in there, I don't care. I just want less hassle when I travel, and that's the only reason I got the vaccine. And they kind of force you to it. They say, look, if you want to travel, you want to document, this other country wants to accept you, you got to get the shots. And you say, I'm not going to get the shots. I'm going to tough it out. Well, they're going to make life miserable on you, believe me. You're going to have to get that vaccine if you want to travel. If you stay at home, no problem. I wouldn't have gotten my vaccine if I wasn't traveling at all. I wouldn't even bother. But I'm going to be traveling. Okay, fella says, who would have thought COVID will allow to create the communist world as in China or North Korea? We are heading in that direction very fast. What worries me most is how easy most of the people believe the big lie and how easy for governments, corporations it is to introduce the regime. Freedom will become a wild fantasy. Okay, I know a little bit about communism because I dedicated so much of my life to it, and what I can tell you is communism is nonsense. There is no such thing as communism. As far as freedom is concerned, I'll give you a little anecdote. I think it was in the 70s. Someone in the United States, a reporter, or one of these shows, they interviewed a Soviet. And I don't know who he was, but the guy said, you Americans, you think you are free. We know we're not. And I think that pretty much synthesizes it. Some people, we're all in a prison. We're all in jail, okay? But some people think they're free because they can walk around the jail, and other people are aware that they can't get out, and they know they have no freedom. And that's more or less what it is. All governments are dictators, dictatorships. Okay? And so it doesn't, one way or another. It's that some governments make you believe that you are free. So that's my take on that. As far as all these governments that say, oh, we're a communist government like Cuba and North Korea and so on, no, they're known correctly. The correct term, which is the one they use, okay, is that they are a dictatorship of the proletariat. Okay, that's what they are. What is a dictatorship of the proletariat? First and foremost, it's a dictatorship. Okay, and the way they look at it, they're working towards the future. It will be our great-grandchildren who will enjoy communism. Yeah, but see, if you're an atheist and you know you're not going to go to heaven, right? Well, you may not want to wait till you are reborn, 5 generations later to see what came out of the world. No, you're going to live your life today. And your life today is dictatorship, and it's these rulers who are there and saying, oh yeah, someday we're working towards the future. Someday we will have communism. And where does that leave me? Well, you have to support us. That's what you got to do. You got to send your taxes. You got to fight in the military whenever they invade us. You got to do all these things so that our future children will live in this paradise. And meanwhile, see, the rulers, they live in great style. Like if you go to Cuba, you see the big guys up there. Oh, they eat chicken, they eat meat. They're the meat eaters, as some of them call them, down at the bottom. The people, they eat what is called this boniato. Boniato is a type of potato that grows on the island. So we have the boniato eaters and the meat eaters. That's how the society is divided. And that gives you a synthesis of what communism, equality is about, Equal, we were all born equal. So that's my take on communism in a nutshell. Okay, another fellow says, if your rule about inbreeding holds true, it must apply in microcosms like isolated populations. Okay, small isolated populations ought to face rapid extinction, okay, from lack of genetic diversity. Maybe not. Okay. Yet many species have survived on one island for so long that they evolve into a distinct breed or race. Okay. Isn't genetic quality more important than diversity? Okay, good question. Enabling people to survive and reproduce who would naturally have died lowers the genetic quality of future generations. Is diverse but poor quality genetics really better than narrow but high quality genetics? Extreme inbreeding, this is his conclusion from that, or where he leads to that, right? Extreme inbreeding prevents genetic defects from being corrected. But if the genetic quality was already high, there may be no serious genetic defects made apparent by inbreeding. Okay. Another fellow along the same lines, okay, says the following. He says, the risk of food scarcity is possible, but more likely won't be a complete extinction. Well, he's just got to become more familiar with the theory that I put forth. I don't think he's aware of it, okay? But it says, some will survive, and I've addressed that issue. No, whoever survives got a big problem, okay? And that's a long story, but for sure they won't reproduce, okay? About loss of genetic diversity, not necessarily bad to have useful selected traits, more or less along the same lines as this other fellow. However, for humans, okay, natural selection no longer happens now. All sort of people breed, so bad genes are passed on. A significant portion of the educated middle class does not breed enough. Again, people have this mistaken idea that's got to do with poor people breeding, okay? And that's not totally true. 19th century, it was the rich people who procreated. So do a little bit of history, look up the past, and you'll find out that it was the rich people who had children, not the poor people. It was the other way around. You don't believe me? Go to the Bible. Okay, and you'll find out that Israel, Jacob, yeah, he had what is it? He was a cattle rancher essentially. You know, he not cattle but sheep or whatever they had in those days. He was a rancher. He was a rich man, and he had 4 wives. You know, with the 2 slaves that he slept with. And he had 12 children plus a little girl there, right? So it was the rich people who procreated. And why? Because they wanted to bequeath their land, their whatever they worked for throughout their life, they wanted to bequeath that to the next generation. So it's not true that poor people breed. It's people who are in the country primarily who breed. When they come to the city, they stop breeding. Maybe not the first generation, for sure the second generation. Women, especially women, right? But men too, but mainly women, when they come to the city from the country, you know, they still might have children or they might bring the children with them, but those children, they will not reproduce. And they're still poor, but they're not going to have children because they're already in the city and they don't have the economics to maintain those children. So they're not going to have just children for the sake of having children. In fact, they don't. Okay, so look up, again, this transition from the country to the city. That's what produces children, okay, when you're in the country, when you have these open spaces. Says that the middle class doesn't produce enough. This could cause a genetic regression overall. Mixed race couples introduce some genetic diversity. This happens more and more. And again, all I can tell you, inbreeding is a bad deal, no matter how you look at it. And I covered that a couple weeks ago. Here you have Charles II of Spain. He was called El Hechizado. He was from the Habsburg family. And his great-great-grandfather, Charles I, okay, Charles V of the Holy Roman Empire, Charles I of Spain, that's why this guy's Charles II, and all the Philips that went in between, they all had the Habsburg chin. And he was born, they say, retarded. That's why he was called El Hechizado, the bewitched, because he was not mentally sane. And there are different theories on that, by the way. But for sure, you know the case of Alexei Romanov. And he was a great-grandson of Queen Victoria. Okay, and in the family line of Queen Victoria, 9 people had hemophilia. Why? Because they've been intermarrying for who knows how long, inbreeding. The Amish have been inbreeding for 300 years. They have all kinds of genetic diseases today, including mental problems. Okay, and humans, we've been inbreeding for over 200,000 years. We have not mixed with anybody else. And so, yeah, I don't think inbreeding is a good deal. And you can justify it any way you want, saying, oh, we have the good genes, the bad genes. If we eliminate the bad genes, we're still okay. And animals that are on an island, you know, a few animals there with the same genetic code. They're okay. Um, all I can tell you is don't inbreed. If you inbreed, you're going to die. You can't continue inbreeding forever. Okay, you might do it for non-geological time, maybe 100 years, something like that. Sure, you cannot do it for forever. Okay, in the end, inbreeding is the end of a species. In fact, I argue that inbreeding or lack of genetic diversity is what eventually causes the extinction of a species in a background extinction. Their population pyramid overturns, then they can only inbreed, and they inbreed themselves to death. They don't continue forever. But if you look at some animals for a short while only, a few years, they say, well, here we have a few animals on the island, and they all have the same genetic code. Yeah, I'm wondering how long that's going to last. Is it going to last 50 years, 100 years, 1,000 years, 1,000,000 years? No, that's the end of those animals. Okay? So that's all I can tell you. You can believe whatever you want. I'll tell you my theory, and my theory is that inbreeding leads to extinction. You have created a new branch of science, one guy says. Extinctiologist. No. A paleontologist is an extinctiologist. Okay? The only job a paleontologist has is telling you how species became extinct. That's what paleontology is 150% about. Once he figures out how extinction happens, both background, meaning one species, or mass, many species, we're done with paleontology. We don't need paleontology anymore. Okay, we're done with it. Anything else is known as stamp collecting. This thing about collecting bones in the field, dusting them, assembling the bones for a museum, that's not paleontology. That's stamp collecting. Paleontology, extinctiologist. You got to tell me how species died in the past. Okay? And he asked me to go and check this guy, Michael Cremo. And this fellow says that, or believes or theorizes that humans have been around for 40 million years. That it's a mistake to say we've been only around maybe for 200, 300,000 years. We've been around for 40 million years. That's his argument. Too lengthy to cover here, but my answer is, my short answer is no. This is what happens when people find something in the field. They interpret what they find and they reach these outrageous conclusions. You got to use your brain, not evidence. Evidence is not sufficient to create a theory. It helps, but mainly it helps to convince people, including yourself. That's different than theorizing and saying, okay, if this is true, what can I explain with that? Okay, and that's when you run into trouble. To say that humans have been around for 40 million years because you found, I don't know, a bullet in the rock dated to 40 million years ago, and you say, see, there were humans here because this bullet could have only come from them. Well, maybe there are many other types of explanations for that, and not the one people like this gentleman is thinking of. Okay, so theories, they have to be rational, and rationality works more or less hand in hand with common sense. Okay, it's not an exact match, but you got to use common sense, the least common of all senses. Okay, another fellow says, I have a terrible suspicion why they want to vaccinate at all. Okay. Bill says that humans practically no longer have any genetic diversity. Yeah, we've lost genetic diversity. We are all essentially clones of each other. 8 billion clones for the most part. I mean, there are differences, obviously, but the differences we have could be cosmetic. Okay. They're not really profound. So whoever you marry today, you're marrying your brother or your sister from a genetic point of view. That's how close we are all of us on Earth today. We descend from the same billion people in 1820 who descended from the same 300 million at the beginning of the Christian era, who came from the 10 million who came maybe 10,000 years earlier. And we didn't come from all of those because, again, you have bottlenecks, population bottlenecks, some disease, war, whatever, that came in, chopped a big chunk of population. And then from there, what you have is a smaller base, which is the founder effect that creates the next generation. And if you do that many times, well, all you're doing is streamlining the genetic code. That's where we are today. Okay, so that's the argument. Okay, could it be that they want us to create diseases through vaccination? So we put a vaccine, okay, in your body, like they put in my body, and what this does is compel you to your body or you, right, if you're going to procreate, right, to adjust to the new vaccine, right? So now you change your code in relation to that. Maybe not you in one generation, maybe over 2 or 3 generations. And suddenly we have more genetic diversity because now we fought against a new environmental problem, which is the vaccine, the poison they put in your arm, okay, or in your veins or whatever. This is more or less his argument here, okay? So that individual from diseases and the species become immune, and thereby a quasi-new genetic diversity develops through vaccination. In short, so that the human species does not die out immediately. It exists much longer. Okay, that's his argument. Okay, and what can I say about that? All I can say, I don't think we're going to create a new diversity, more genetic diversity through vaccines. Okay, this takes many generations, and it takes us moving into new environments. And there are no new environments we can move into, even if we move to Mars, by the way. Okay, let that be clear. You go to Mars, you bring your house with you. You bring your air, you bring everything that you need to live in Mars. So even though it's a totally different environment, it's not like you move in there and start breathing, CO2. No, when you go there, you're going to take your own air, you're going to, your whole equipment with you. You're probably going to grow the same plants that you have here on Earth, et cetera, et cetera, et cetera. So it's like you never left home. You're not forcing your body to adjust to anything. That's different than when we migrated, okay? Like humans apparently migrated from Africa to Europe. That's at least a theory that I vouch for. Neanderthals evolved in Europe, okay? They evolved with the cold. And so, that's when you have genetic diversity. And you create more and more genetic diversity when you first settle, but then you enter this period where you're more or less stationary, you're sedentary, you get used to the endemic diseases, you get used to the cold, and after that, it's all the way down. You lose genetic diversity through bottlenecks and founder effect, a whole cycle of them over thousands of years. And so, if you look at the Neanderthals, they've determined through genetic analysis that they lost genetic diversity. There was no genetic diversity among Neanderthals. They say there was none among the Denisovans. Okay, none of them had any genetic diversity left at the end of their lives, and that's where we're at now. Fortunately, we're not going to die through loss of genetic diversity or population pyramid overturn. We're going to die in a mass extinction, and that's an economic collapse, ecological collapse. Okay, here's something that came in the news related to this subject. Okay, it's this lady, and says the Antwerp Zoo says woman who had affair with chimp asked to stay away for his health, for the chimp's health. And she said, "We're having an affair." What is this all about? Are we sleeping with chimps now to have what's it called? Trying to get a human Z out there, a mixture between humans and chimpanzees. You get a human Z. Well, that if we could have one like that, well, I'm sure the genetic would be a little of that individual would be very different than the rest of humanity. Okay, and here is what this lady says. Okay, she's from Belgium. Says I would say, she says, let's wait until it starts here. She kisses the the chimp. I guess the chimp's wife got jealous and asked for a divorce. And she says she's having an affair with a chimp, and says he's 38 years old. Okay, And I'm saying, okay, maybe it was the age difference between them or something. Maybe he did not give his consent. Was that it? Maybe his wife asked for a divorce because he was cheating on her. You know, the chimp cheating on a chimp. They tried to create a human Z in the 1920s, a Russian guy, and he failed miserably. He went out there and asked for women who were willing to be donors, and a woman came forward and she was impregnated by the chimp, and it never happened. Nothing came out of there. Okay, and this is the issue. A lot of I get people who say, "Well, humans will sleep with anything," and I have to believe these people are mentally retarded. Okay, they're mentally retarded. They don't understand what the issue is. You know, the guy can go behind a cow and do whatever he wants. You know, you're not going to have a minotaur come out of there. The issue is reproduction, not sex. These people are thinking of sex. They're saying, we'll have sex with anything. Yeah, you can have sex with a fly. You can have sex with a spider. You're going to get Spider-Man. You're going to have sex with a fish. You're going to have Aquaman. I mean, what is this? We're talking about reproduction. See, the issue here is that the people in the genetic world, especially the Max Planck Institute, they claim that humans slept with Neanderthals, and out of that union, we have all these missing links that lead to us, and that we lost eventually all that genetic influence from the Neanderthals. They died out, and we have Neanderthal blood in us. What they suggest, in fact, more than suggest, it's proven already, so you got to accept it, is that the Neanderthals died because they interbred with us. It's the admixture theory. Okay. Anyways, for this lady that she slept with the with a chimp, she didn't really sleep with a chimp, but that's what it looked like at first. That's why it went on the news. And but there was a big change in all zoos on Earth because of what she did. You know, it used to be that they had this sign up there says, please don't feed the animals, okay? And now they had to change it. They said, please do not have sex with the animal. So, yeah, please don't have sex with the animals. Zoos are off limits, okay? Maybe circuses as well, okay? So don't sleep with the animals. And as far as the Max Planck Institute is concerned, you know, they say we slept with that guy and that the females are unfaithful women. You know, they're always unfaithful. And they were sleeping with that monster there. Yeah, sure. And so what they do is, what they've done since then is make Neanderthal ever more like us. If you look at, you know, the sequence this century, well, the 20th century, is that Neanderthals have become more and more like us over the years. You know, they started with that gorilla you saw there, and they ended up with a blonde, blue-eyed guy from Hollywood. That's how. That's been the what is it? The evolution of Neanderthals in the 20th century. Believe it or not. Okay, folks. We're going to be doing a little bit of physics now. Okay. And what do we do today? Well, we're going to find out something about the speed of light, or velocity of light, if you will, you know, whichever one you want. Okay. And there's two problems in the speed of light. And, you know, they say that you have Einstein on one hand, through special relativity. He had this principle of special relativity. One of them says that light travels at a constant speed, okay, through the vacuum. Let's clarify that. Through the vacuum, light travels at a constant speed. Speed is 300,000 kilometers per second, rounding off. Okay, and no one can live with that. And to this day, we're talking about 100 years later, people say something else. They talk about faster than light. They talk about tachyons. You've got what? The Enterprise. It travels much faster than that. It travels at warp speed. What is warp speed? It's the speed of thought. You think you're on the other side of the universe and you're there. And you say, well, okay, that's Hollywood, that's science fiction. No, no. Believe me, they're talking about, again, tachyons, so they ponder those things. They talk about phase shifts within light. They sneak it in any way they can. And so even though on the one hand they say light travel, that Einstein proved mathematically, et cetera, that light travels at 300,000 kilometers per second and it doesn't travel faster or slower in vacuum, they overruled that. To this day, they keep overruling that, and they want you to believe that, theories can be overruled. So Einstein's a hero, but then we overrule him anyways because we want to travel faster than light. Why do we want to travel faster than light? Because otherwise, NASA, European Space Agency, Japanese Space Agency, all these agencies are dead. They're dead because there's no way we can reach the nearest star. Proxima Centauri, 4.3 light years away, round trip, close to 9 years. We can't go to the nearest star at the velocity of light. We got to improve on that. And we're billions of years away from that speed. In fact, Einstein said you can't travel at the speed of light because you become energy. So we got a problem because on the one hand, they give they bow down to Einstein, okay? And they say, oh, Einstein, he was so great. He discovered, among other things, this constancy of the speed of light. And then on the other, they say, by the way, we're going to overrule him. We're going to throw all that away because we need to make people believe that you can indeed travel faster than light. And the question is, why can't you? Because, particles travels faster at the speed of light, right? Okay, fine. Why can't they travel faster? What's the physical impediment? Okay, so that's what we're going to be looking at. And we can trace it to two problems. Okay, the first problem is language. Mathematical physics thrives on irrational language. And the second problem is the word object. Mathematics has no use for objects, so they never worried about defining the word object in a scientific way, and they use the informal version, which is an irrational version, which is the one of ordinary speech, which is the see-touch criteria. Okay, if you can see it or touch it, that's an object. Okay, and so that brings in experiment, because experiments can only be done on things that you can see or touch, and the invisible stuff that serves as mediator, like for gravity, magnetism, well, we're going to put particles in there. Particles, 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 and more particles. It's all done with particles. And when you say, well, the explanation is irrational, I say, well, that's philosophy. That's more or less what we have today. And so we have two problems. And the main one, at least the starting point, is language. We have a problem with language. And so here we have one fellow, and he says the following. He says, saying that plasma is not an object because you have to ionize gas first is like saying that steam is not an object because you have to boil water first. Plasma is what? Charged particles with separation, not separated, just like steam is water molecules with separation. God can create a cloud of steam without first needing to create water and boil it. I don't know who it is you think keeps claiming that plasma involves motion, but they are feeding you baloney. All substances look solid when you take a freeze frame. Well, so many errors. Absolutely so many errors. Let's go with the first one, and that's that steam is a concept. There is no physical object called steam. Sorry. Okay, again, you're using the language of ordinary speech, okay, the one mathematics has taught you, and so people just follow this this language that mathematical physics has, and they go with it, and we're challenging that language. Okay, so here you have steam. Okay, steam. What is steam? Steam is water in the gas phase. Okay, due to evaporation or due to boiling, where heat is applied. That's Wikipedia. Dictionary says more or less the same thing. Steam, water in the form of an invisible gas or vapor, changed to this form by boiling. Okay, so what is steam? Steam is boiling water, hot water. Okay, you have to have the hot in there. Whenever you have an adjective in front of a noun in physics, okay, in science, not in ordinary speech. Okay, let's get that straight. Whenever you have an adjective in front, or an adverb for that matter, but that's in front of a verb, right? Whenever you have an adjective in front of an object, a noun of physics, only objects can serve as a noun in physics. You have an adjective in front of a noun. Always, 150% of the time, it's a concept. Okay? There is no such thing as a black cat in science, in physics. There's a thing called a cat. Okay? No such thing as a black cat. Black cat, concept. You're already comparing something. Okay? And same with steam. Steam, if you just point to a freeze frame, you call it gas, vapor, you want. Okay? But that thing you're looking at, steam, is not steam. It's gas. Okay? Now, if you want it to be steam, you got to have it moving. Okay? So let's get that one first in there. Okay? And here's the other issue. We talked about ions there. What is an ion? Well, it's a gas that's been, where you take an electron out of the atom, essentially. Okay? That's what it is. So what is it here? Well, when you look it up, you find that every time you look at the word ion, you find all these processes. They're all in motion. They're called ionization. And people say, well, ionization is not an ion. Well, you're wrong. You're wrong. Ionization and ion are synonyms. Okay, there is no physical object called an ion. Okay, let's get that first before we move to plasma. Okay, so here we have an ion, a particle, atom, or molecule with a net electrical charge. Electrical charge. What is charge? Well, charge is something in motion. In fact, the value on charge is 1.6 times 10 to the minus 19 coulombs. And what is a number? Number is something in motion. Okay? Counting. That's what number is. So if an ion has something to do with charge, electrical charge, again, a adjective, we got a problem because it's a concept. Okay, and so that's the first thing you got to absolutely understand. Ion, an electrically charged atom or group of atoms formed by the loss or gain. Loss or gain are both verbs. Okay, I know this is news to you. Loss and gain are both verbs. Okay, so there's motion already embodied in the definition of ion. Okay, more fundamental than that. If you can define the term, it's a concept. Okay, in science we do not define objects. In science we point to objects and name them. Table, chair, light, lamp, whatever. You can't, you don't define objects. You point to them. Okay, in physics. In religion, that's something else. Mathematics, ordinary speech, we don't care about any of that. In physics, you have to point and name. Okay, so if you can define the word, 100% of the time, it's not an object, it's a concept. Okay? Okay, so it says the word ion was coined from the Greek ion, a cation, right, is something that moves down, and an anion is something that moves up. Move, okay? It's moving. Loss, gain, okay? Ions are formed by the gain or loss of electrons, okay? And atoms can be ionized by bombardment with radiation or the transfer of electrons between atoms and molecules. So, yeah, if what is plasma? Plasma is ionized gas. Then it has, the word plasma is already, it already embodies motion. That's different than gas. Gas does not embody motion, okay? I can point to gas, and the word gas does not contain any motion, intrinsic motion in it. On the other hand, the word plasma, there is motion embodied in the word, in the definition of the word plasma, because it's being ionized in the photograph. That's what you're saying. You're saying you can take a snapshot of plasma. No, you cannot. If you take a snapshot of plasma, what you have is gas. Okay, and you say, well, but it's ionized. What do you mean it's ionized? You mean something happened in the photograph? You removed an electron? Is that what you're saying? It's charged? So no, the word plasma embodies motion just like the word steam embodies motion, just like the word ion embodies motion. Okay? And yeah, it's very hard for some of these people, especially from the electric universe, to understand that. Okay? So here we have hydrogen atom. If you ionize it, you don't get an ion. What you get is proton. Proton is an object. An ion is not an object. Okay? An ion is something that happened to an atom. Okay, and I don't know how else to get that through to you. Again, you got to use a little more intelligence, but if you don't have the intelligence, well, I can't help you. Okay, here's, again, the difference between gas and plasma. Gas you can take a picture of. Okay, I don't need to have gas moving in order for it to be gas. Plasma is something else. Plasma, you need to remove the electron from at least one atom for it to be plasma. Otherwise, it's not plasma. Okay? If I freeze the universe, all those electrons move back probably to their atoms. If I stop the whatever influence the gas is under. Okay? You have to do something to the plasma, and the word plasma already embodies motion. And unless you get that through your thick skull, well, you'll be a follower of the electric universe. That's how bad it is. Okay, so yeah, anyone dealing with the word plasma is, cuckoo in the head, mentally retarded. Okay, we treat all people who use the word plasma as mentally retarded here. Okay, and again, so all these people from the electric universe. Okay, another fellow, he raises this issue. He says, Maxwell described light as propagating wave of electric and magnetic fields. In mathematical physics, he calls it physics, okay? A field is a quantity. What is it? It's a quantity. Is a quantity a physical standalone object? No, quantity is a concept. Okay, there's no physical object called quantity. He's saying, these are his words. He got this, okay? He's right, but I'm just saying that these are not my words. These are his words. Represented by a number. What is a number? A concept. The word number means to count. It's a verb, not a noun in physics or for the purposes of science. In ordinary speech and mathematics, yeah, they think number is a noun. It's not a noun in physics. In physics, number is a verb, the verb to count, okay? So if it's a quantity or a number or an amount, we don't care. Concepts, dynamic concepts, counting, okay? That has a value. What is value? A concept. For each point in space and time. He's right. That's the definition of the word field. A value at each point in time. You see it there at the bottom. And we have values, numbers, and they make these numbers vibrate. Very scary stuff. Field starts vibrating, all the numbers start vibrating, and it usually goes from stronger to weaker as you go out farther away from an object, whether it's an electrode or whether it's the earth, a gravitational field. It gets weaker as you go out. That's the notion of field. What are they talking about? They're talking about the values of the strength of the field at each point in space around an object. Okay, so he's got it right. That's the definition for the word field. If you can define it, it's a concept. There's no physical standalone object called field. Okay, and it says this has led physicists to consider electromagnetic fields to be a physical entity, he says. Physical, well, we need to determine it's a physical entity or a concept. Is it an object or is it a concept? Can't be both. Concepts we define, object we point to. Objects have shape, concepts don't. So God cannot be both a human, figure that creates the universe and also love or intelligence. No, no, God cannot be a concept and also a physical object. He's got to choose. And he can only exist if he's a physical object. If he's a concept, he doesn't exist. And nevertheless, is that what you pray to? You pray to a concept? Hopefully the concept has an ear to hear you, you know. Okay, so yeah, we got a problem with language. That's my point here. This language, as you can see, comes from reifying these concepts into objects. Okay, they convert concepts into objects. They talk about field, they talk about energy, they talk about mass, and everybody thinks they're talking about physical objects because they say phrases like transfer energy. What do you mean you transferred energy? How do you transfer a concept? They transferred information. How do you transfer information? I mean, did you carry it with your hands? How do you transfer information? What have you how does it transfer information move? You know, so they talk about sending information at the speed of light or whatever. Nonsense. That's mathematics. In science, we don't transfer information. It's very scary stuff. Okay, don't ever do that. Okay, so the problem is language. And here, let me show you a little story. Okay. Here you have Martian. He comes to Earth. Okay. And he looks like that cat there. Okay. And what does the cat do? Felix, you know, he revolves this mass, and he does it with so much energy, rolls it around, throws it, and breaks the window with force. That's more or less how a mathematician explains a physical interpretation, explains how the window broke. You know, so the window broke because what? Mass was thrown with so much energy that the magnitude of the force shattered the glass in 1 picosecond. Those are the concepts they use, and they say, we explained it. They explained it. They explained the mechanism of how the window broke. No, I don't think so. I don't think that's an explanation. Let me show you how a physicist does it and how the language is totally different, okay? And this is how we do it in science, okay? And the language of physics is illustration, not mathematics. And we say that the window broke when a horseshoe went through the glass, okay? And I hope you can see the difference. There is a little bit of difference, qualitative difference here, okay? In one case, they're throwing concepts around which they reified. And in science, we don't do that. In science, we have to explain how the window broke, okay? So this is the first issue. Okay, hopefully that became clear, okay? And what's the issue? The issue here is language again. Okay? That's the major problem. And here, let me surprise some of these people. And I know I'm going to get a lot of feedback, it's called, for this. These are the verbs, concepts that people mistake for objects. Steam is a concept. It's a verb. Okay, it's boiling. You don't concentrate on the word water, you concentrate on the word boiling. Okay, that's what steam is. Wind, it's moving air. Okay, so is a tornado and a hurricane. All those are moving air. The object is air. Okay, and you're moving it, and then we call it hurricane. Under this circumstance, tornado under that one, if it whirls around or whatever. Vortex, no such physical object as a vortex. When you take a snapshot of a vortex, you get a cone, usually an ice cream cone. Okay, plasma concept. Okay, it's a dynamic concept. You have to ionize almost every atom in the soup. Okay, that means the electron has to be removed from the atom. Okay, in order for it to be plasma, and you have to be doing it. And you can't do it in a single frame, obviously. Okay, so if you're doing it, you got a verb there, you got a movie. Plasma is a movie, always a movie, because you're doing something to the atom. And again, electric universe people have tremendous mental barriers to understand the language, and that's what we're talking about here. Language. You got to get the language straight before you can do physics. These people never do language. They consider that a job for English majors, maybe librarians. That's why they don't define words. They look them up in the dictionary and say, well, let's see what the dictionary says. Well, we don't have a single definition worth anything for science or for physics in the dictionary. So don't look at the dictionary, because they're all the words have been misdefined for the last 10,000 years. And yeah, gas is a physical object. On the other hand, ion is not a physical object. An ion is what? A concept. Ion means that you're removing an electron from an atom. When you do so, at least for the hydrogen atom, what you get is a proton. Proton is a physical object. Because you can talk about that ball in the center. We'll even take the quantum version, no problem. But if you're going to talk about that ball in the center, that's a physical object. We call that a proton. When you put the electron back in, we call it an atom, as is. Okay, we have problems with going around, but because it's a composite object. Okay, so it's not really an object. But when we talk about atoms constituting molecules, we treat them as objects. Ion is something else. Ion means you're going to do something to the atom. Plasma, you're going to do something to the gas. Steam, you're going to do something to the water. Wind, you're going to do something to the air. When you do something, it's a concept, dynamic concept. It's no longer a physical object. Like I like to say, a jumping kangaroo is not a physical object. The object is known as kangaroo. Okay, here's some other words that let me put over here, that we usually, mathematical physics reifies. Electricity, there's no physical object called electricity. Sorry. Electricity is a verb, it's a concept, dynamic concept, in fact. And when I tell that to people of the electric universe, they say, well, why don't you put your fingers in an outlet? You'll find out if it's an object. Well, that's not how we determine objects in science. In science, we define the word object, and if it meets the definition of the word object, it's an object. Otherwise, it's not. See how easy it was? But you can go ahead and put your fingers in there to try to prove that electricity is an object, okay? And what's funny about the electric universe, they never defined the word electricity. They've given up on that, as I've shown in the past, and they say it's an undefined word, but let's continue. You know what we're talking about. That's the way they put it. And electric is in the title of Electric Universe. And then they even worse, they say that all galaxies are interconnected by these filaments. How can they be interconnected by filaments if the atom of the electric universe is the planetary model, and electricity, according to them, is this flow of electron beads from atom to atom? How do you create continuity with a little bead going from atom to atom? How do you create these filaments? So they have a contradiction, because they want to say that the filaments unite or hold together all these objects. And it turns out when you go to the nitty gritty, all these filaments are made of atoms, and the atoms are all planetary atoms with the beads going from one electron, from one atom to another, right? And so when you have the flow of these beads, how do you create this rope, this filament that pulls everything together? You're building something continuous with discrete parts. You can't do that, not in science. It's irrational. Anyways, time, force, mass, energy, wave, charge, number, all of these words are concepts, they're verbs, okay? Displacement, perturbation, and so on. So you can't use this as nouns, you can't use them as objects, which is exactly what mathematical physics does. Okay, and just in case, here are the adjectives and adverbs, okay? Shape is an adjective, okay? It's a qualifier of a noun called an object. Objects are, shape is a property, a qualifier of objects. So shape, anything related to shape, is an adjective. Okay, sorry, I know you learned that this is a noun, not in physics. Okay, so you got to learn the language of physics in order to be able to give physical interpretations. Straight, okay, people confuse it with rectilinear. They say, I traveled straight. That's in ordinary speech in mathematics, not in science. In science, you travel rectilinearly, okay? And you can say rectilinear travel or whatever, but the point here is that straight is an adjective, rectilinear and rectilinearly are adverbs. Rectilinear can only be motion. Same with curvilinear versus curved, bent, and warped, okay? Location, angle, perpendicular, all those are adjectives. Those are they tell you it's a property of an object. There is no physical standalone object called perpendicular, therefore there is no noun in physics called perpendicular. And you can't talk about perpendicular as the subject of a sentence, not in physics. The subject is whatever object there is, and perpendicular is what it does, or actually in the case of perpendicular, how it's positioned. Okay, so it's a static concept, therefore it's not an adverb. Okay, so all these words, you got to relearn them. Forget about ordinary speech, forget about mathematics. These are how the words are used in physics for physical interpretations. Okay, direction, matter. What is matter? Objects that exist. What does exist? Exist is an adjective, it's not a verb. You don't begin to exist in physics. Physics, an object that has location being a static concept, okay? Object has no motion, the word object, embodied in it. So an object with location is what exist. And all you're doing is qualifying the object. Okay? So exist is an adjective. And so on down the line. So you got to learn these terms for the purposes of physics. Sorry if your religion says something different, okay? But that's how we're going to use these words here so that you're in tune with what we are saying here, okay? Okay, so now here comes the Martian again. We had the cat, right, a little while ago throwing the stone through the window. This time we have a Martian, okay? He comes and visits us, okay? And he waves his hand, okay? And suddenly a window breaks, okay? And you say, how did he do that? And, I mean, did he use magic? Is he using spirits? He just waves his hand and from afar and suddenly the window breaks. How could he have done that? Okay? And what is the issue? Well, the issue is that maybe he's not using magic. Maybe he's using something that you can't see. And it turns out, you ask him and he explains, look, I did it with a rock. What do you mean a rock, a stone? I don't see anything in your hand. I just saw that the window broke. And he says, well, it turns out that, you know, I did it with a rock, but you can't see the rock because what happens is that this rock gives off ultraviolet radiation. And you can't see, you earthlings, you cannot see an ultraviolet light. And that's why you thought it was magic. But if the guy, you know, makes it appear like he just draws it or shows you the movie, maybe a special movie that comes from Mars or wherever, right? And he shows you what he actually had in his hand, well, then it's no mystery. Then it's kid stuff. But see, while you couldn't see the stone, then you thought it was magic. You thought the guy was just throwing, you know, nothing. He just waved his hand. That's as far as you're concerned. And so why am I bringing this up? Well, we have this situation with light, and especially with the velocity of light, okay? You can't see the mediator of light. In fact, you know, here you have magnetism. You can't see the mediator of magnetism, okay? You don't see anything between these two, but it causes some magic, some incredible magic, pulls these two things together. Here's another magic trick, okay? I let go of the pencil, falls to the floor. You do it many times, you'll find out it always falls to the floor. And so what's the issue? The issue is that you can't see the mediators. And so you got two choices, okay? You either say that there's nothing there, no mediator, or, you know, meaning you do it with spirits. Because if there is no mediator, what you're telling me is that pencil falls always to the center of the earth and one magnet attracts another, simply because either there's ghosts and spirits, or you're going to introduce black magic. You're going to say, ooh, two magnets come together. Is that what happens? Or is there a physical object that you can't see or touch? Which one is it? So, you know, you have the materialists that say there's a physical object in there, I just can't see or touch it. And the spiritualist, which is 99% of humanity probably out there, that says, oh, there's nothing there, it's spirits. And because I can't see or touch it, there's nothing there. Those are the two choices. And of course, most of humanity just believes there's nothing there because you can't see or touch it. And that's our daily experience, that you got to see and touch something for it to be a physical object. And that's easily solved. We redefine the word object so that it doesn't include see or touch. Okay? We say that an object is that which has shape. Okay? And so here are some examples of quantum mechanics where, because you can't see or touch the objects, okay, they've come up with, let's see, there we go. Here we have entanglement, okay? And so what happens here? Well, you're saying that one object influences the other object with nothing in between them. Called entanglement. They call it Einstein-Podolsky-Rosen, the EPR test. And what they say is that one ball affects the other one goes clockwise, the other one counterclockwise, and vice versa, at a distance, without any mediator being in between them. So this is what's so scary, that they give you these explanations, and people just believe, and they just swallow them because they come from PhDs. They say, well, he studied at the university, he must know. I don't care where he studied. I mean, if he's going to tell me that there's nothing in between these two objects, this one affects that one over there, well, we got two choices. Again, we either put spirits and do things with black magic, or we have to assume that there is a physical object that we can't see or touch. Okay, so those are the two choices. You have no other choice. Okay, another experiment that shows that quantum also does magic, okay, without objects, is this one. They say, look, particles can be at two places at the same time, and it can be excited and not excited at the same time. And how can you understand this? You know, how can a particle be at two places at the same time? So they have all these explanations, and we have to assume that quantum is simply not a rational theory, because these are their physical interpretations. And again, they do it all with magic, and they do it all with ghosts and goblins, spirits, acting in between two objects. And it's like people have gotten so used to it, they don't even question it anymore. They say, well, quantum has been proven, because otherwise you wouldn't have a computer that works, right? So that's the answer you get, the kind of answers you get. Okay, here are the three possibilities, at least today. We used to have only two, now we have three. Okay, you have the particle hypothesis, you have the wave hypothesis, and now we have the rope hypothesis. We have three versions of what light might be. And the first question I've got for you is, here you have particles up there, okay? Why can't those particles travel faster? Why can't they travel faster than light? Why can't they travel faster than 300,000 kilometers per second? Okay, that's the question. Same for the one-way waves. No physical object called wave, but let's concede that. Let's forget about fighting that issue. Why can't the wave travel faster? What prevents the wave physically, right, from traveling faster? Do you have an answer for that? Can you think about that and give me an answer? Okay, and so here you have, again, the quantum versions, okay? Let's see. In the case of the rope, I don't know what happened here. Oh, I think it's this one, hold it. See, here you have the particles and the waves. And the question is, here you have different speeds for the particles. Let's assume the one on top is traveling 300,000 kilometers per second. Why can't these particles travel faster, like the ones in yellow there? And how about the wave? You have a wave that travels slow and another one travels fast. Why can't we travel faster than light? And here on the right-hand side, you see why we can't, under the rope model. The rope model explains quite well that frequency is inversely proportional to wavelength. Okay, if it's inversely proportional, it means that the velocity of light is constant. All we're changing is frequency in exchange for wavelength. Under the rope model, it's length versus the number of links. Okay, and so now we have an explanation for why the velocity of light is constant and why you cannot travel faster than light, because all you can do is increase the frequency at the expense of wavelength and vice versa. That's the situation. Okay, so we don't have an explanation from quantum mechanics. Let me get rid of these here. And we do have an explanation under the rope model. That's the main point. Okay, so someone asks, he says, give me a second here. Says, what's the earliest instance of c equals frequency times wavelength that you have found? I can't seem to find the innovator of the equation. It's an important question. It's an important question because it's so hard to find this type of information, one. And second, because no mathematician is specifically aware of this equation, c equals frequency times wavelength. I mean, they're aware of it, but it's like no one pays attention to it. They don't ask, why is that the case? Why does frequency exchange with wavelength? Why did Einstein say that light travels no faster if you throw the ball, if you throw the photon ball from a moving train, why don't you add the speed of the train to the speed of the photon ball? That was the issue. And they have no explanation for that today. Under the rope model, you do have an explanation, but nobody's familiar with this equation. It's not imbued in the minds of mathematicians at all. They heard about it, maybe they forgot about it, but they don't care about it. Okay, and so this is the history. Okay, just for your sake of your interest, right? These were the people who worked on the wave equation. D'Alembert, Euler, and Bernoulli. They were two Swiss mathematicians. And all these people, Lagrange and Maxwell, they all worked on the wave equation, okay? But it was all math. There was no attempt to try to make sense of it from a physical point of view. That's where the problem was. And so it doesn't really matter who came up with it and how they discovered it or what math they did behind it to justify it. The point here is that we have this equation. We're all aware of it today. Nobody pays any attention to the equation. No one tries to explain it, of why it's the case. And for the first time, we do have an explanation. We're saying, if you take the rope, all you can do is, if c is equal to frequency times wavelength, in other words, little c being the velocity of light, 300,000 kilometers per second, all you can do is change the number of links for the link length. And here you see it, there's the magic trick. The links became longer and you have fewer links. So we can explain that equation, which is the equation of a rope. There's no other entity that can simulate that equation. So if you want evidence, well, for those people who like evidence, who think evidence is part of science, there you have evidence. Try to explain why that's not the case. Okay. Thought I had a glitch there. Okay, so what are the conclusions? Let's see if we can move on to them. If I can get it up here. Okay, conclusions. Mathematical physics thrives on irrational language. Okay, they move the mass, they transfer the energy, they also transfer information. Very scary stuff. Mathematical physicists propose irrational physical interpretations simply because they can't see or touch the invisible, intangible mediators. Okay, so they can't see the mediator of light, and so they put particles in there, for example, but then they don't explain why light cannot travel faster than 300,000 kilometers per second, because there's no reason not to. Why can't the particles go faster? Why are they limited, physically limited, at 300,000 kilometers per second? Under the rope model, it's very easy. One frequency exchanges with wavelength. How do you explain that with particles? So clearly the particle hypothesis, meaning the quantum hypothesis, is irrational. We cannot explain anything with it. Okay? And as an object is not that which you can see or touch, which takes the mathematicians to the lab. They're trying to see and touch that which is invisible and tangible. Okay, an object is that which has shape. And it doesn't mean that you can see or touch it. So there's no use in going to the lab. You can stay at home and just try to visualize, think. And you'll reach your answer not by going to the lab, you'll do it with your brain. Okay? And quantum particles and waves are not objects for the purposes of physics. And the quantum particles are the zero-dimensional point particles, remember. That's not an object for the purposes of physics. It's a concept, not even a rational concept, but it is a concept nevertheless. And the electromagnetic rope explains the constancy of the speed of light, which quantum cannot. Okay, let me answer some of the questions that people asked since last time. One fellow says, you can try to prove your orthodox belief that the ground under our feet is orbiting the light source we observe moving across our sky each day. I mean, in the sun, right? Use science. I'm not a flat earther. Well, it looks like you are, huh? I'm interested in your evidence. Well, the answer is that we don't talk about proof, we don't talk about belief, and we don't talk about evidence in science. That's totally religion. Why? Because evidence is introduced to persuade, convince, recruit the jury. That's what it's for. You're trying to convert people, and that's why you introduce evidence. Evidence has to do with proving and changing your beliefs, and all that has to do with religion. We don't do that in science. In science, we explain so that you understand. You can reach your own conclusions in your dark basement. We don't care. It has nothing to do with science. Okay? And along the same lines, another fellow says, all these people are into proof and evidence. Okay, says, sorry, but your experiment for gravity is not a true scientific experiment. Thank God, because in science, we don't have scientific experiments. No such monster in science. Okay? So scientific experiments, we have no idea what that is. You should go to a church and ask your priest what a scientific experiment is. Okay? In science, we don't do experiments. In science, we explain them. Okay? In physics, we explain them. Okay, things falling is the natural effect observed. Yeah, great. Things do not always drop anyway. Okay, we float in water and hot air. Or helium balloon rises. Okay, so he's saying that, I guess, violates gravity or the law of gravity or whatever. Okay. How does your presumptive assertion account for these conditions? What is the demonstrated mechanism of action? Well, I explained that many times, but the issue here is his language talks about demonstrating. One thing is demonstrate like an explanation, physical interpretation. I make a movie of it, and in that sense, I demonstrate what is happening in the invisible world. If he's talking about demonstrating in any other sense, like maybe an equation, or I'm not sure, or running an experiment here in front of him, yeah, here's the experiment for gravity. Okay, you let go of the pen, and it falls to the ground. There, I demonstrated gravity. Again, we're talking about explanation versus description. Okay, so the question is, what does he mean by demonstrate? You have not proved any valid hypothesis. Thank God. Yeah, in science we don't prove. Okay, again, these people talk about evidence, descriptions, proving, running experiments. None of it has to do with science or with physics. Physics, we explain. That's what physics is about. That's what science is about, explaining. You have not established any true insight into the cause of the observed effect. Yes, I have. You just missed it. I missed the explanation, some other videos that I have out there. Humans do not hold any insight into what they term gravity. Well, mathematicians don't. We do. We have an explanation. We have a physical interpretation for how gravity works. And that's that as an object approaches another, the acceleration is due to the fact that the ropes are fanning out more and more and more the closer two objects get together. Why? Because all their atoms are physically interconnected. Okay, and so that's in a nutshell the explanation. I've got many videos on the issue. Just got to look up gravity under the site. Okay, we have these people who believe that light goes through. They use that term, light goes through, light goes through, light goes through. In fact, someone started today with that, light goes through. When are they going to forget about light goes through? No, light doesn't travel. Light twirls in place, so there is no going through. So how does light go through a glass lens? Well, I explained that the other day. They're all interconnected. All the atoms are connected. And so signal is relayed from atom to atom. That's how it goes in a nutshell. Look up at a couple of videos behind this one and you'll find how light goes through. Okay? No, light does not go through it. It's relayed. That's how it goes through. If the substance of light is smaller than the substance of the glass, and again, they're looking at little particles going through other particles, and whether there's enough space for the particle to go through. Okay? If the substance of light is larger, okay, and then truth is that we have no idea what light is. Very simple. Propose an idea of what light is. All you have to do is propose a model, and then we'll know what light is, according to you. Okay? Now, if you don't know, well, that's then you shouldn't say we have no idea. You should say I have no idea. Okay? But yeah, in science, it's very simple. You want to know what light is, propose a mediator for light, and you'll know what light is. Okay? Then you can explain how light behaves to all of us. Okay? How's that for an action item? Atoms are modeled and not actual. Yes, exactly. You're totally right. We model atoms. Okay? Now, are they actual? Mother Nature determines that. If you hit it on the nose and you figured out how the atom, what the atom looks like, and what light looks like, etc., what magnetism, whatever object is in there, Mother Nature knows what it is. Okay? And she says, this guy's right, that guy's wrong. She knows that. We don't know. Okay? We don't know that. All we can do is model it, model our atoms, and light, etc., and present it to someone so that person can understand it. That's the way science works. Okay? Whether you believe, whether you have enough evidence to believe, whether you proved, we don't care about that in science. That's religion. Belief has to do with religion. Subatomic quantum physics is science fiction. Totally agree there. Okay? Yeah, it's science fiction, but it's not what you think. It's actually irrational. Okay? Quantum mechanics, like I explained a minute ago, is irrational. It says stuff like that a particle can be at two places at once. It says that it does entanglement without a mediator. Quantum mechanics is irrational because of that. Also because it reifies concepts, turns them into objects. Okay, so it's not that it's science fiction, it's that it's totally irrational. You cannot understand it or even visualize it. You cannot visualize energy. Okay, because energy is a mathematical concept, so you better not be able to visualize it, okay, or you got the wrong definition of energy. Okay, human knowledge is a facade of understanding with little real insight into existence at all. They all still think they are going around a vast empty void on a spinning spherical wet rock. God help them all. Flat earther, yeah, obviously. Okay. Yeah, spinning, what is it, wet ball? Absolutely loved it. So we're in a spinning wet ball. We don't know why. But it turns out that, like I explained last week, if every atom of your body is physically attached to every atom on Earth, now you know why you don't fly out of the Earth, why you're pulled towards the center, and why water curves around the Earth. Okay. Okay, what is your definition for data and what is your definition for information, Bill? Well, we don't define the word information because it has nothing to do with science. Okay? And we don't transfer information. That's very scary stuff when the information, goes across your screen. Oh man, that's very, very scary stuff. But all I'll tell you about information is that it's even more irrational to say that you transferred information. Okay? Information is what someone receives. He gets some signal and he processes it, and the conclusion of that process is known as information. Information is not what you send out, so to speak. Information is what you receive. It's on the receiving end that you can talk about information. Okay? You cannot go in there and say, I'm going to transfer information. No, you can only receive information because information means that you receive some kind of signal, something there, okay? Or you see something. you take it into your head, you analyze it, you come up with a conclusion. That conclusion is what we call information. Now you have information. Until then, you had no information. So the guy sent you something. What he sent you is a signal, maybe electricity or whatever, okay, a torsion. And whatever machine you use to detect that detects some blip and gives you some result. You analyze it, now you have information. So just to put it in these terms, information is not what you send, information is what you receive. Okay, I hope you understood. Okay, another fellow says, it's why they call it quantum theory, just the same as we call it electrical theory. It's a theory, a calculated guess and an educated guess, I guess. Could be wrong. No, again, quantum is not wrong. Quantum is irrational, okay? And here are some reasons why it's irrational. Reifies concepts, states that a particle can be at two places at once. The quantum particle is not a particle, it's not a corpuscle, it's an equation, okay? It's what is it, a wave function or whatever? That's what a particle is. It's a concept, a mathematical concept. Proposes the planetary model, can't tell you why the electron beam doesn't fall to the center of the atom or fly away, okay? Theorizes that light is a wave, no such monster as a wave, so that's the end of that. And does entanglement with spirits. And these are just some off the top of my head, okay? So, you know, again, quantum is not wrong. It's not even wrong. It's irrational. Okay, let's get that straight. And here you have criteria for rationality, okay? We have to treat objects as objects and concepts as concepts. What an irrational individual does is reify, converts concepts into objects, and that's the main one. So any theory of physics where they turn a concept, especially a mathematical concept, into a physical object and start moving it around, scary stuff, that's what we define as irrational. And then there are other criteria for irrationality. It doesn't stop there. If you're using inconsistent definitions or you don't define your words, that's another irrationality. That's very typical of mathematical physics. They haven't defined any word. They don't know what mass is. They don't know what time is. They don't know what space-time is for sure. It's four-dimensional space-time. And they tell you, well, we don't know what that is, but let's continue. No, not in science. Science, you got to define the key terms that make or break your theory. Okay? And that's where mathematical physics fails in its entirety, and that's another criterion for irrationality. Another one is that the theory doesn't follow from the hypothesis, the assumptions. So you have a set of assumptions, you know. I always give the example, you know, you go to court and you present a gun as evidence. Your Honor, here's the gun, exhibit A, okay? And then you explain your theory by saying the person was poisoned. Well, hold it. Why did you present the gun? You know, I thought your theory was that the victim was shot. Turns out that your theory is about being poisoned, or maybe a knife stuck to her back, you know. So again, the theory has to follow from the assumptions. Okay, and there's a couple more there. You can read them. Okay. Paul says, where does the slack in the ropes go as objects near each other? And how does a rope stretch indefinitely without needing more material? And apparently new on this site because doesn't know about the thread, single thread, okay? And you can find that in the book that's in the description, okay? So it's a free book, downloadable book. Essentially, the proposal is that there's a single thread that underlies everything in the universe, every bit of matter and every rope that interconnects any two atoms. Okay, so that's the foundation. And so this thread does not extend or get smaller. It's not a rubber band. It's not elastic. Okay, it's a thread made of a single piece, malleable. Okay, just like a river. Okay, it's made of a single piece, but it waves, it moves. Okay. And it builds the ropes and the atoms that are interconnected by the ropes. Okay, so that's the foundation. And so the ropes do not bend because they're always taut, and there are other conditions. And again, I urge you to read the book. Very easy to read book, not too lengthy book, very heavily illustrated, so you can look at the pictures and understand quite a bit. Okay, almost all of it. And that's all I can tell you. It's there. It doesn't stretch, and the slack comes from ropes and atoms that are behind the atom that you're analyzing. Okay, so there is no stretching, there is no elasticity to the rope, okay, or the thread that builds the ropes and the atoms. Okay, so all I can do is tell you to read the book, and the book is very self-explanatory. Okay, so that's all I can tell you. Okay, okay, give me a second here. You got another comment here? Question? Fellow says, light is everything in the universe. All the elements have vibrational frequencies that are created by light as plasma, as the magnetic universe turns, creating it. Voila, life is light. Oh my God. We have the electric universe, this is the magnetic universe. Okay, another thing. The spirit soul of the universe is light. Okay, whatever he said there, I have no idea. And the design creates life as an evolving form of the design. Design? Design means there's an intelligence out there that is designing. Watchmaker, maybe? Sounds like it. I mean, apparent in studying magnets, electricity, plasma charge, separation in space. Yeah, we don't understand squat of what you said. All we have is religion there. Okay, sorry. We get rid of this guy. And another fellow along the same line says, theists not really say that God is immaterial. We just haven't saw God, but every true believer sense God. Okay. Well, you got to tell us whether God is an object or a concept. Okay. See, we can't see concepts. I can't see love. I can't see intelligence. I can't see the grace of God. So the question is whether God is an object or a concept. Now, if God is that guy there, that's an object. And I can understand a theory saying, not that I believe it, but that I can understand a theory saying God may waved his magic wand, here. Magic wand, you need the magic wand. God waved his magic wand and he made the universe. Okay, we can understand, we can see what's going through your mind. Okay, not that we agree or we believe, but we can understand what you're trying to say. Okay, because we can see God with his wand, and yeah, I look like God with a wand. Okay, but if God is a concept, if God is intelligence, if God is love, we cannot imagine him creating the universe. So it doesn't follow from the assumptions. Okay, so you got to define what God is. Is God an object or a concept? If God is an object, maybe he can hear you and you can pray to him. But if God is a concept, I don't think he have that concept called God has ears. Okay, so you got to determine first what God is. Okay, and with that I say, may your God go with you. We'll see you on Wednesday. We're going to be here with my son Uns. We're going to do the monthly recap.